皆さんこんにちは。このパートでは実際の科学論文の書き方についてマルコム先生が解説してくれます。今回のトピックは研究計画、材料と方法、結果、図表の書き方です。ワークブックをお持ちの方は58ページから65ページをご覧ください。それではマルコム先生、お願いします。
So this is part 5, and it's the first of two segments on how to write the scientific paper, which is the central part of this whole OCW course. So these are the topics for the first of the major sections on writing the research paper. And it looks like a long list, but in fact there are two major topics within this list of topics: materials and methods and results. Items 1, 2, and 3, research design, materials and methods, and analysis of data, are all part of the section that you'll write on materials and methods. And likewise, for the results section, we're going to be considering whether to include tables and figures, and then other ways to write up the results. So these three parts here are included in how we write the results. So before you even think about doing any experiments or field work, I recommend that you sit down with your peers, your colleagues, and your supervisor and discuss the hypothesis that you're trying to test or the experiments that you plan to do. This is your research or experimental design. It's not possible to design your experiments or field studies after you've collected your data. I've seen examples where data has been collected in certain scientific fields and without any intention as to where the data is going to be used. No direct sense of direction at all. So it's important to have a research plan or research design. When you have your research plan, then you can in fact begin to write your materials and methods section, because it's part of the materials and methods section. So that's something you can write even before you've done your experiments or field studies. Now we come to what is familiar to you perhaps as the materials and methods. The materials are either living or non-living things. Plants and animals will be included in the living things, and metals and rocks and other kinds of non-living things might be the subject of your work. We'll look at some examples in a minute. Once you've identified the materials, then you can begin to deal with how those materials are going to be used. So this is the next part. How are the materials used? Well, maybe to take measurements. That's a very important way. Maybe we are going to do field procedures. Here's another important way. And what kinds of experiments and field studies are you going to do? So that's the third aspect of the methods. And finally, again, we're still talking about the materials and methods. You have all this data. How are you going to analyze it? You're going to write it up. You're going to describe the statistical techniques that you're going to use. What a good idea to have, before you even begin your experiments, some idea of what kind of statistical methods you're going to use. And are you going to build mathematical models? In some areas, especially field studies, but in many areas of science, you can build mathematical models. So this is how we can divide up the analysis of data. So let's move on now to how do we write the materials and methods section. This is an example from a paper on geothermal energy. It was a paper written by some researchers in Germany who were trying to identify a source of geothermal energy to heat a university. And they drilled a hole, or had a hole drilled, to see if they could get enough energy to heat the university. They drilled the borehole and identified the temperatures inside the borehole, here is the fields part, but they also took some samples into the lab and did laboratory experiments with them and took measurements. So they divided their materials and methods up into two parts: measurements in the laboratory and measurements in the borehole. So let's look at the way in which they did this, and the first part tells us that in the laboratory they measured thermal conductivity, and this was in these units, watts divided by meters times degrees Kelvin. In the field they took direct measurements in the borehole, and they were in degrees Celsius. So it's important to identify the correct units you're using and describe the measurements that you took and the procedures. So part of their paper involved explaining how the laboratory and field measurements were done. Here's another example from a different type of paper. This is a paper written about the effects of pesticides on grassland birds in the United States. Birds of the grasslands produce nests in the spring. Those nests contain a number of eggs. So we have immediately three pieces of information here. We have when did the nests appear, how many nests were there in a particular area, and how many eggs were in each nest. And what they found, sadly for the songbirds, was that the nesting survey showed that the birds were declining. The populations of the birds were declining because they were producing fewer nests and fewer eggs. Why was that? Well, some aspects of this grassland area. There was agricultural activity, so they measured intensity of agricultural activity. How much farming was going on around the areas where the nesting birds were found. How much herbicides and other kinds of pesticides like insecticides were used, and what was the influence of those. So this is a slightly different way of looking at materials. Their materials already existed because somebody had collected the data. Then they analyzed them. So that was the methods part. They analyzed pesticide use data, the bird trend data, and then various agricultural variables that I just described, how much intensity of agriculture and pesticide use. And finally, they had a significant section on statistical treatment of the data, correlation, regression, and so on. So how do we write the materials and methods section of the paper? Well, here's some ideas for you to think about, and questions, in fact, that you should ask yourself when you come to write your materials and methods section. What was your experimental design? This gives you a sense of direction. You have it written down even before you did your research. What materials did you use? Describe them. You can do that very early on in the work. You can, in fact, do this before you do any experiments. What were the materials used for? To take measurements, do experiments, conduct field research. And how did you do these? So this is the methods part. You've got the materials here and the methods that relate to those materials. How did you do the tasks? And then finally, these two parts, how did you analyze the data collected, and did you build some sort of models, mathematical or otherwise? And sometimes these last two parts are put in a separate subsection of the materials and methods section. So in the materials and methods, it's important to just restrict yourself to the materials and methods that we've just talked about. Don't include information from other parts. For example, from the introduction. You don't include information from the introduction in the materials and methods part. Okay, so that's a look at the materials and methods that are going to give you results. So now we come to the central part of all papers, the results, what you found as a result of your experiments or field studies. So you have three choices for how you report, how you describe the results. The first, must occur, must be described in words. You must describe your results in words. You may choose to also add one or more tables and one or more figures, but these may not be necessary. So the important point here is everything must be described in words in the results, but it can be supplemented with tables and figures. So first thing you do, here's the action. Are you going to use a table? Yes or no? Are you going to use a figure? Yes or no? Here's an example of a table. This is a table taken from a paper on an anti-malarial drug, artemisinin. And this has been one of the favored anti-malarial drugs in recent years. In fact, somebody received a Nobel Prize for discovering this drug. The paper is about the course of history from the year 2000 to 2011 in populations on the border between Thailand and Myanmar. And the paper starts out with simply identifying the number of people that were surveyed in those two areas. So the first part here lists the number of people on the Thai side of the border. And you can see the numbers, you can look at them and say to yourself, well, they seem to be about the same. And then on the Myanmar side of the border, there is a noticeable increase in the population between 2000 and 2011. This increase is significant, as we'll see in a moment. So here's the data. The table is nicely presented. It has a nice title here. It adds information. The columns are labeled, population, year, and the rows are also identified. And footnotes are easy to read. It's important that if you have footnotes, your readers can read them, especially if it's a presentation. So what are the significant aspects of those results? Well, on the Thai side of the border, the population numbers remain stable. People are coming and going on the Thai side of the border. On the Myanmar side of the border, population increased over that time. A little more than 10 years, there was a dramatic increase, in fact, in the size of the populations in the villages. And we're told it's 4 times what it was in 2000 at the end of that period. So we can write the results based on the information in that table in 2 possible ways. We can start the sentence by referring to the table. As you can see from Table 1, migrant numbers on the Thai side of the border remain stable. Or we can keep the table information at the end or later in the sentence and put it in parentheses if necessary, which is what the second sentence here does. The populations in villages on the Myanmar side of the border increased by 4 times. Table 1. So we don't necessarily have to give a high profile for the table, but we have to identify it. It must be there somewhere in the sentence. Now let's look at a figure. This figure has all the features that it should have. It has a title, and the title should be telling you something useful. So this is validating the higher taxon approach. This is an approach, a technique that they developed in their paper. The higher taxon approach refers to some of these types of organisms. Some are invertebrates, some are vertebrates. And they looked at the actual numbers of species where it was known on this axis, actual number of species, and the numbers on the scale, and predicted numbers of species over here. And they found something rather remarkable, that using their technique, they were able to have a graph, a figure, that was a straight line. And if you look at the top left here, you can see some extra bits of information they put on that graph, which were very useful. Namely, the correlation coefficient was very high between actual numbers and predicted numbers, and they could define a mathematical model which was a straight line, which is here. So let's summarize that. These are the observations based on that figure that you would describe in the written part of the paper. So here are the two observations one more time. The figure shows high correlation between actual number and predicted number of species. The result is supported by a mathematical model, equation of a straight line. So if we write this information in sentences that might be included in the results section, it might look like this. We found a high correlation, there it is, came from the figure, between the actual number and predicted number of species. Figure 2, in this case we're referring to the figure in parentheses. The finding is supported by the mathematical model, which is in the top left of the figure, and the results validate the higher taxonon approach for estimating species number. So they gave convincing evidence in this paper of a method for estimating the number of species that are found on land and in the oceans in planet Earth. So how do we write the results? Well, there are various aspects here which we've covered. Will you use a table, a figure, both or neither? It's unusual that you would not, if in a realistic scientific paper, it's unusual not to have at least one table or figure, but in some cases that may be the case. Write the parts of the results that relate to the information in the figure or table. That's the second way to do this. And write about any statistical techniques. And as before, statistical techniques and mathematical models can be put into a separate section. And there are some types of science papers in which it's preferable, because there is so much statistics or so much mathematical modeling or some other type of analysis, that you put them into a separate subsection of the results. So for more information and examples of materials, methods, results, tables and figures, very large section, please see section 4 of the workbook. Thank you for your attention.
いかがでしたか？科学論文でどのように実験計画や方法、結果、仕様を書くかが分かりましたね。次のパート6では引き続き実際の科学論文の書き方についてマルコム先生が解説してくれます。パート6でまたお会いしましょう。
See you in the next part!